In this video, we will talk about Chapter 16, Part 1, Expected Value. So to get us thinking in the direction of expected value, we're going to start with this little introduction here. Suppose that we counted the number of children in each of our families and recorded the data below. For this example, we're going to let capital X represent the number of children. And we're going to suppose that we choose someone from the class at random. Now, I went through and I just randomly made up numbers here since we're not all together. These probabilities are definitely not accurate, but this would mean that 3 out of the 15 students just have themselves their only children. 4 students had 2 children in their family. Okay, and we would go on. 6 plus is just 6 or more kids. Only one person fell into that category. So this table is called a probability model. It's sometimes called a probability distribution or a probability distribution model. If a problem asks you to create a probability model or a probability distribution model, you would create a little table like this where you have all of the different options and the probabilities then right next to them. What's nice is there's a really quick way that we can verify that this is valid. All of our probabilities should add to 1. Number 2 says, is 5.7167 a possible value for x? And we want to explain. So in this case, x is representing the number of children in a family. Is it possible that somebody has 5.7167 children in their family? This would be a definite no, and the reason why is that x in this case, the number of children, can only be whole numbers. It's not possible in this case to have 0.71 of a child. Now, is it possible that we could have collected data on something else where 1.7 was a possibility? Absolutely, but in this case, since we're looking at a number of children, this is not possible. Okay, on the bottom of this page, we're going to start talking about some vocab for random variables, which is what this next unit is all about. Okay, a variable whose numeric value is based on the outcome of a random event is called a random variable. So examples would be summing the result of numbers after 2 dice are rolled. You could randomly select a person, record their weight. We could flip a coin and record the number of tails that we get each time. There's tons and tons and tons of different random variables. We've been using a lot of random variables as we've been going through our probability unit before winter break. So think about all of those different scenarios. Those are random variables. Now, when we're talking about random variables, we are going to use capital letters to denote random variables. So that's why we used a capital X in that example above. And what's kind of tricky here is a random variable is different than an algebraic variable. So a variable in an algebraic equation is an unknown value that can be calculated. So for example, if I give you the equation 10 plus x equals 13, you could subtract this 10 over and you would find out that x is equal to 3. Okay. On the other hand, a random variable has not just one number that it could be equal to, but it has a set of values. And any of those values could be the resulting outcome. For example, in our intro activity, we looked at the number of kids that were in a family. There wasn't just one answer. It's not just x equals 3. It's x equals 1, 2, 3, 4, 5, or 6 plus. Any of those are possible outcomes. Now there's 2 types of random variables. We have discrete and we have continuous. So discrete random variables is where we're going to start our studies. They're a little bit easier to work with, so we'll start there. And then after discrete, we'll look at continuous random variables second. So discrete random variables within a range of numbers, discrete variables can take on only certain values. For example, you flip a coin and count the number of tails. The number of tails can be any integer, so any whole number between 0 and infinity. There's no 1.7, 1.8, it's either one tail or two tails. There had to be integers. Discrete random variables are typically countable. They're things that you can count. Okay, continuous random variables are a little bit different. In contrast this time, they can take on any value within a range of values. So for example, let's say we randomly select an individual from a population, record their height. The heights could be any value between 0 and infinity. For example, I could say that somebody's just 60 inches. I could want to be very precise and say that they're 60.5 inches. I could keep going here, making it 60.52, 60.535. Really, I could do 60.535297641. Is that still a range between 0 and infinity? Absolutely. Continuous random variables are harder to work with because they're not countable. Instead, these are measurable. So these are things we're going to measure rather than count. Example 1 says, which of the following is a discrete random variable? So I'm looking for discrete. This is something that I can count. Part 1 says the average height of a randomly selected group of boys. Height in this case would be a continuous random variable. So it's a random variable for sure, but it's not discrete. 2 says the annual number of sweepstakes winners from New York City. This is something that seems random to me, so it fits the random variable category. And is it discrete? Is it something I can count? Yes, it definitely is. There's a definite number of winners. Maybe it's 0, maybe it's 4, but it's something that's countable. And 3 says the number of presidential elections in the 20th century. Again, this is something that's countable, so I would agree that that is discrete. So 2 and 3 would be my answer. The first thing that we'll look at with these random variables is finding the mean or the expected value. So the mean or expected value of a random variable is what we expect to happen on average over time. Now this is something that's super important. I can't stress this enough. This is not what we expect to happen every single time, but it's what we expect to happen on average. If we sat here and we had this random event occur over and over and over again, it's what we expect to happen over time. For example, if I'm flipping a coin, I expect that I'm going to land on tails 50% of the time. Does it mean that when I flip the coin 10 times, I'm going to get exactly 5? Not necessarily, but as I continue to flip over and over and over and over again, I sit here for the rest of my life and I flip a coin, eventually it should even out to be 50-50. So the expected value of a discrete random variable is denoted by a capital E, so we'll write this as E of x, or we will use the Greek letter mu. Both of these are interchangeable. Now the formula for finding expected value, or the mean, so I'm going to put E of x. What this tells me to do is take the sum, so I'm going to use my big summation here. Sum means that we're adding. We're going to add up all of our possible values, so I'm going to use x there, times the probability of that thing occurring. So we would take one of the outcomes, multiply it by the probability that that outcome occurs. Add it to another outcome times the probability that that thing occurs again. Okay, we'll look at an example here so you can see this expected value in action. So example 2 says your statistics teacher puts you in charge of creating a carnival game for the fundraiser. You decide to have people roll a colored die. 3 of the sides are green, 2 are blue, and 1 is red. If a player lands on green, they will earn 3 tickets, landing on blue earns 4, and red earns 6 tickets. There's 2 things that we want to do. We want to start with creating our probability distribution chart, so listing the different outcomes, the probability of that outcome occurring, and what we earn or what we will get paid for that outcome. Once we have that filled out, then we can figure out our expected value to determine how many tickets we should charge. So I'm going to look for one of my possible outcomes. It looks like we're going to be rolling a dice here, and one option is that I land on green. Now it told me 3 of the sides were green out of 6 total sides. I'm just going to leave it as 3 over 6. You could reduce, that would be fine. I personally like to just leave those probabilities as is. And if I land on green, it looks like I'm going to earn 3 tickets, so my payout is 3. Okay, the next option I have is landing on blue. There are 2 sides that are blue, and blue earns me 4 tickets. Only one side is red, so that's my next option, and that one earns me 6. Now, one of the nice reasons that I like to leave my probabilities unsimplified is because it's a quick way to check. These should add up to 1 here, so we're at 1, 2, 3, 4, 5, 6. This does add up to 1, so I know that so far I'm on the right track. This next question asks me how many tickets we should charge to play the game. Now, if I want to know how much I should charge, I want to know what we can expect people to win. So the first thing that I'm going to do is find the expected value. I want to figure out what I expect people to win on average. So expected value is that capital E, or you could write it using your mu. What we're going to do is take the payout, each payout, and multiply it by the probability of that payout occurring. So I'm going to take 3, that's one of my options. There was a 3 out of 6 chance that we win 3 tickets. We're going to add it to the next option. So the next is that I win 4 tickets, and I have 2 out of 6, plus 6 tickets, 1 out of 6. We're going to go ahead and type this into our calculator. And we get 3.83. Okay, now this 3.83 means that on average, as people play the game over and over and over again, on average, we expect them to be winning 3.83 tickets. Now what's confusing is that an option for playing just one game? No, someone either wins 3 or 4 or 6 tickets. 3.83 isn't even an option. This is an average, so we're saying on average, I'm expecting them to win this amount. Now, if I'm expecting people to win this on average, and I'm trying to probably make a profit here, right? Most of these are carnival games, you're trying to make money somehow. So how many tickets would you charge? I would say that I would charge probably more than this here. So I'm going to say at least 4 tickets. So I can make a profit. Could you say that you want to charge 5 tickets so you make a profit? Absolutely. Can you say that you want to charge 10 tickets? I mean, sure, but I don't think anyone's going to play the game if you're charging 10 tickets because the most you can win is 6. So I'd say your best bet is to charge 4. You could argue 5. I wouldn't really play your game if you're charging 5 tickets though, because there's only a 1 out of 6 chance that I'm going to get anything back. Sometimes students get confused when they're finding that expected value, whether they should put the outcome or the payout. In this case, I can't put the outcome in my equation because I would be taking green times 3 out of 6 plus blue times 2 out of 6, and there's no way I can be multiplying colors. When you're finding that expected value, make sure you're really thinking about what you're trying to find. In this case, we're trying to find how many tickets we are expected to win, so these values here should all be tickets. Alright, example 3 says London loves to bake, so she decides to open a bakery called Bennett's Bakery. It costs her bakery $6 to bake a cake. If it sells on the first day, she charges $15. If it sells on the second day, she charges $9. They're not as fresh, so she's reducing the price a little bit. Otherwise, the cake is thrown out, which is very sad. The chances that the cake will sell on the first day are 65%, and the chances it will sell on the second day are 23%. Given that X represents the profit that London's Bakery is going to make, we want to complete the probability distribution chart. So on the first day, and do notice that this probability chart is now going in the opposite direction. It's vertical instead of horizontal. So my first outcome here is that it sells on the first day. Remember that X is that profit. So in order to find the profit, we're going to have to take however much money she's making and subtract the cost that it took to make the cake. So on the first day, London was able to charge $15 for her cake, but I'm going to subtract $6 because it did take her $6 to make that cake. That means London is really profiting $9. Probability-wise, it's that capital P. It says there's a 65% chance that she sells on the first day. Second day, she can charge $9. Again, we're subtracting 6 because it still took her $6 to make that cake, so she's only going to make $3 on the second day. And there was a 23% chance that it sells the second day. Okay, our third option is the cake doesn't sell. If it doesn't sell, London's going to make $0. But we are still subtracting the 6 because she spent $6 to make the cake. So her profit is -6 here. Don't want that to happen. I am noticing that they didn't give us the percent for that not sold. So in this case, we have to remember that in our probability model, all of those probabilities should add to 1. So we're going to take 1, subtract 0.65, subtract 0.23, and I'm left with 0.12. I'm going to stop here. I want you guys to try this next one where you find the expected value of London's profit. Here's my work for that expected value. The only thing that was a little bit different with this one is that one of the profits was negative. You could put a plus minus here, or you can just do a subtraction. It is totally fine to be subtracting here if that person is losing money or losing tickets or whatever the case may be. Hey, I like this next question. It's a little bit of an extension. So it says the bakery is open Tuesday through Sunday. So we're open Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. It averages selling 50 cakes a weekday. So Tuesday through Friday, they're selling 50. And 75 cakes on Saturday and Sunday. So Saturday, Sunday, they sell 75. What is their expected profit a week? So we're looking for how much we expect London to be making throughout this entire week. So I'm going to kind of split this up into two things. It looks like we have different numbers for weekdays versus weekends. So on weekdays, we know that they sell about 50 cakes. And I'm going to multiply that with the average price that we think she's going to profit, times also the number of weekdays, because I know this is going to happen not just on Tuesday, but it's also going to happen Wednesday, Thursday, Friday. That's 4 times. So 50 cakes, each making an average profit of $5.82, times the 4 days that it's happening, gives me $1,164 profit expected for the weekdays. Okay, weekends, she's profiting a little bit more, or she's making more cakes, sorry. She's making about 75 cakes. We're still expecting her to make about $5.82 per cake, but this time there's only 2 weekend days. So 75 cakes times the $5.82 times the 2 weekend days gives me $873. I'm going to add these together, giving me a total of $2,037. Okay, now is this exactly what London's going to profit each week? Definitely not, right? This right here was just an average, and we're using that in there. Again, these 50 and 75, that was an average. So this isn't exact, but on average, as we look at weeks and weeks and weeks and weeks, this is what we expect London to be making. All right, last example here. Alexia is a workout enthusiast, so she decides to open her own gym. Her gym is offering a promotion in January to encourage new members to sign up. Upon signing up for a new membership, the customer will be given 5 cards, an ace, jack, queen, king, and a 10. The customer will turn 1 card over. If the card is the ace, the customer will get $150 off of their membership dues. If the card is a king, the customer will get to pick up another card, and they will earn $100 off their dues if the second card is the ace. The customer will have to pay full price for all of the other draws. We are asked to determine the amount that the gym should expect to pay out. So we're looking for the expected value of what that gym should expect to give for their promotion. Now, I'm going to get you guys started on this one because I do think the probabilities are a little bit tricky with these cards. So it looks like customer is going to be given 5 cards. So right away, I'm going to start with a tree to kind of help organize. I have ace, jack, queen, king, and a 10. Just looking at those 5 cards, there should be a 1 out of 5 chance for each of those. Okay, if the card is the ace, the customer will get $150 off of their membership. So I'm hoping that I get this right here. I get $150 off if I get the ace. It says, if the card is the king, the customer will get to pick another card. So if it's a king, I'm not going to stop right there. I'm actually going to pick another card from there. So branching from this king, I'm now going to have an option to pick the ace, jack, queen, can't pick another king because I already have it, or the 10. So there's 4 more options there. Each of those should have a 1 out of 4 chance. Now, if I get the ace on the second draw, I'm going to win $100 off. So this is what we're looking for this time. And remember back in our last unit when we looked at these probabilities, whenever we were working with tree diagrams, we multiplied straight across. So 1/5 times 1/4 would give me a 1 out of 20 chance that this thing happens. Okay, it says that the customer will have to pay full price for all of the other draws. So all of these right here, that customer is not getting anything, getting $0. So this is 0, this is 0, and this is 0. Now before we go find that expected value, I would make a little diagram here, probability distribution chart, where you could list your outcome, the probability, and the payout. Okay, now the first option, the best option, was that you get an ace. We said the probability of getting an ace was just 1 out of 5, and you're going to get $150. I'm going to look at my next option for actually getting money off. It looks like I can win $100. And that was a 1 out of 20 chance. In order to get 120, I have to get a king, then an ace. Now technically you could make this probability distribution chart as big as you wanted. You could say Jack, $0, 1 out of 5. But really what I'm focusing on is the pay. We're all about the money here. So I'm just going to lump everything else together and say that what are the chances that I win $0. So I'm just going to say all other options, all others. And again, you could do this the hard way and add up all these little probabilities in here. But I would use the fact that these probabilities have to add up to 1. So again, let's just take 1, subtract 1 out of 5, subtract 1 out of 20, gives me 0.75, which if I change that to a fraction, you should know is 3/4. Okay, go ahead and pause your video. I want you guys to take it away from here, finding the amount that Alexia's gym should expect to pay. Alright, here's my work for that expected value. I did switch up my notation this time and used mu, but hopefully you found that Alexia should expect to pay an average of $35 per customer.